it looks like there's almost 40 people here today for the class, which is awesome. So thanks for joining. My name is Andy Vassar. I'm the CCIE Collaboration Instructor at IP Expert, and obviously new to the team. Previous instructor, his name was Vic. Great instructor, worked with him before and had some good experiences with him, but I'm going to be here trying to help you guys get your CCIE collaboration. That's my goal. That's my full-time goal. So even outside of the class, if you guys have problems or trouble or anything, just email me and I'll work to help you get through it. So looks like I don't know if you guys have all used the HDILT interface before, but it looks like everybody's pretty much in. The chat window obviously is used pretty well there. Looks like everybody knows what they're doing. But the buttons below we have, and I'm looking over here to this side of the screen. I'm just going to be looking at the chat window, so I'm not paying attention to you. But so we have the raise hand thing. So if you have a question, you can hit that. Also, any questions, just pop them in the chat window. I absolutely encourage questions throughout the entire time. It's not going to interrupt anything. I want to try to keep this an open forum, so that way, everybody can learn something. So I think the best way to learn is by asking questions. So don't be embarrassed to ask a question. It's not going to upset anybody. Maybe it'll upset your fellow classmates, but be concerned about yourself. Get the information that you want to get out of this. So, all right. See, we got the there's also the thumbs up button. Feel free to hit that thumbs up button whenever you want. That's pretty helpful for me. Thumbs down, it's also helpful, but I don't like to see it as much. And then we have the laugh and the clapping hands button, and I'll take either of those two. So anyway, let me actually transfer over to the slides here so you can kind of see what we're going to go through today. Put myself in the corner here. What we want to talk about, obviously, is the CCIE collaboration written, and I'm guessing that it's a mixed audience. I don't know the best way to get that without just asking you guys to type, whether you have a CCIE or not, whether this is your first attempt at a CCIE, if the CCIE collaboration is your first attempt at any certification. So I'm sure that there's a lot of different backgrounds here. So see a couple people or one person typing they have their CCIE voice. Good. I was hoping that some people would come into the class with CCIE voice experience. Obviously, collaboration is such a new certification, but a lot of it's based on the CCIE voice. So it's good to have that knowledge going into the test for sure. And it obviously this course is going to try to cover everything from the bottom up. So we're not gonna just get into expert level stuff right away. We're going to try to get into the basics and then kind of build on those basics. So hoping that we can get good participation, good feedback. If you don't understand anything or if you understand something that I'm saying, just feel free to say it at any time. I just want to reiterate that. It's not going to bother me at all. So let's see, get to this first slide here. You can actually see a little bit about me. My name is Andy Vassar, like I already said. I am a 3-time CCIE, just got my CCIE collaboration. Studied for that one pretty hard, obviously, so I'm going to be trying to take that knowledge that I learned from the CCIE collaboration and studying for that and hitting the books and reading the SRNDs and the RFCs and all that stuff and give you that knowledge and try to impart that knowledge to you. So I've been in the networking industry for about 10 years, worked on a lot of different projects, a lot of different types of technologies. I've been in the web design field before, I've been in the database development field, and most recently, obviously, I've been doing networking. Got my CCIE routing and switching in 2008, and my CCIE voice in 2010, and then now recently my collaboration. So I've kind of dabbled in a lot of different things, and I've kind of stuck with the voice collaboration track. So definitely excited to be doing the collaboration. And there's a lot of cool technologies in here that I think are going to be useful to different customers. And for those of you, you might know some of you might know me from my days at Cisco. I worked with some of you actually on this meeting right now. So thanks for joining, Cisco folks. Um, I worked with a lot of great people there, a lot of smart people. So it's not all self-taught. It's a lot of working with great engineers and just getting a lot of feedback from them and a lot of help from them and that kind of thing. But also, it does take a huge commitment on self-study. So definitely want to give a shout out to those people. So I'll get off of this slide here. Let's start talking about the actual exam. What is the exam going to cover? What is it going to be difficult? Yes, it's going to be difficult. I thought it was a pretty difficult exam actually. I had a tough time getting my CCI voice written. What was that? 2009, I think I was taking that, but I took that a few times, and this one was no different. It was very difficult. So I think this class is going to give you a good leg up on trying to get the certification passed. Also, there's a good resource out there now for those of you who hadn't seen it. There's a CCI collaboration quick reference now, which is basically like a study guide for the test. I think it's pretty useful. It came out after I took the written, so I didn't get to benefit from it. But I think if you take this class and you get the documentation, get that quick reference guide and go through it, I think you'll be pretty golden on this test. So there are no prerequisites at all from any other test. I mean, you don't have to have a CCNP voice. You don't have to have any other certifications to take the written. You can just take it. But be warned, it's not easy. So that's kind of the point. I mean, you don't want to just go in there and waste your money. So taking the test is definitely a challenge, and it's a good thing to take this plunge because it's definitely a rewarding thing to get into if you get CCIEs. So like I mentioned, it's an expert level written exam. It's going to be, if you have taken other exams before like CCNA or CCNP, it's going to be a lot different. I mean, they're going to go into a lot more detail. The format's going to be the same. It's a multiple choice kind of test. So I mean, they're going to have different examples, and it's not an easy multiple choice. For example, they'll say, they'll have 4 choices: A, B, C, D, and then choice E will be A and B. Choice F will be A through D. So they're not easy multiple choice tests, of course, but that's kind of the point. So this test basically just serves as a qualification exam for taking the lab. So if you can pass this test, you should have the fundamental knowledge necessary to go take that CCIE collaboration lab exam. But obviously you're going to need a lot of studying and physical hands-on, with the routers, switches, unified communications equipment, phones, that type of thing. So the exam covers everything obviously outlined in the blueprint. The blueprint is basically just, for those of you who don't know, for those of you just unfamiliar completely, the blueprint is just a list of every single topic that you're going to have on the exam. So it's really useful if you don't have something like this, like a course or a book. I mean, you can go through and see like, all right, this is exactly what's on the exam. I got to study the heck out of that to try to figure this out. So let's see. And also, I'm sorry, I haven't really looked at the chat window for questions. Let me go ahead and check that out, see if anybody's got any here. Okay. Is everybody okay seeing everything and hearing everything, and anybody having problems? Okay. So there are a few people that are having some issues there. I'm using, I have it up on my screen over here, obviously, and I'm using Firefox. I don't know if that makes a difference for you guys. Also, there's, I tried it in Chrome. It worked in Chrome the other day too, and I can't speak for Internet Explorer because I'm not a huge Internet Explorer fan. But anyway, definitely, I'll keep checking over the chat window to make sure that all you guys are taken care of there. So moving on here to the course information. This is a little bit late, but congratulations, guys. I mean, you guys have decided to take this plunge into the CCI collaboration, whether it be you're re-upping your certification from CCI Voice, or you're going to go take the lab exam. I mean, congratulations. This is really a great thing that you've decided to do. I can take it from me. I mean, I've got 3 CCIEs now and really enjoy, using them and, interacting with other CCIEs and getting in that special green room at Cisco Live. Just kidding. But congratulations on taking the course. It's really, really a big step in your career. It's going to be a 5-day course. I'm going to do 9 a.m. to 5 p.m. roughly. I mean, I wanted to put that on there so you get a general idea, but there may be some days that are a little bit longer, maybe some days that are a little bit shorter. So we're going to try to take breaks, relatively often. I don't want to lose you guys. And I know, for me personally, being in classes online, sometimes you're like, all right, let's go check ESPN. Let's go jump on a few forums and check some stuff. I mean, I'm bored, I mean, I understand that feeling. So it definitely, it's not the most exciting material, some of it anyway. Some of it's really exciting, but some of it's pretty boring if you've heard it before. So definitely, we'll try to take breaks often so you can reset your mind a little bit and not have to sit at a computer for 3 hours in a row. So we'll take a couple breaks throughout the day. We're going to do it like a noon lunch, noon central. I'm in the Central Standard Time. It's kind of in the middle of probably where everybody's at. So anyway, we'll do a lunch at noon or whatever that happens to be for you. It'll probably end up being answering emails and talking to customers and that type of thing, I'm sure, for a lot of people. And like I said before, this is an open forum class. Please just ask questions. It's going to help me to actually know where you're at in terms of your knowledge level, but it's also going to, help you to get those answers that you really want. So, also I want to say too, the chat window is probably the best way to communicate. You can also communicate through audio, but I'm probably not hearing you because I have everything muted on that computer. So, and it also, there's a little bit of a delay. There's a 1-second delay or so, and that'll prevent you from really hearing me, or for me from really hearing you. So anyway, but the way to ask questions will be through that chat window. Ask questions at any time. The goal is obviously to prepare you for the written exam. The lab exam is a completely different animal. I mean, there are things on the blueprint for the written exam that are just not on the blueprint for the lab. For example, gatekeeper is one of those. I spoke about that in my CCI collaboration lab overview, and it was kind of like, rejoice, the gatekeeper's off. Like I had a tough time with gatekeeper when I was doing CCI voice, and obviously now it's fine. But it's one of those technologies that have kind of been replaced by other things like Session Management Edition and Cube. So gateway or gatekeeper went the way of the dinosaur on that, which is okay. There's going to be a lot of slides. I'm going to try to break those up with demos and diagrams. I have a collaboration pod, so you can kind of see what the rack is going to look like too if you're going to rent rack time from us. So I've got a collaboration pod set up so we can go through and check out phone view, which is going to be a way to connect to your phones, see your phone screens, send phones commands. You can also go to obviously the web pages for the servers, got those all set up, and obviously the rack equipment as well as routers and switches. So the full pod is accessible to us, and we can kind of demo anything we want. So if there's something that you'd like to see that I can configure, then let's go ahead and do it. So, and lastly, want to make sure this is actually told to me at Cisco when I first joined Cisco, and I want to bring that over to IP Expert, is that you define your own learning experience. Everything everything's a learning experience. You can take it as you want, but everything's kind of what you make it. So if you want to learn something, you can do it. Just put in the effort, put in the work, and anybody can get a CCIE as long as you put in the effort. I'm total proof of that. So I'm not going to say ever that I'm the smartest guy in the world. There's a bunch of people that are smarter than me, but if you put in the hard work and get your studying in, get your labbing in, you can take this test down. So here's the agenda that we're going to go through. Today, we're going to cover the Cisco collaboration infrastructure, things like DHCP, NTP, TFTP, protocols like that are going to be on the setup side of things like, registering phones and that type of thing. And then the telephony standards and protocols set of slides, we're going to go through those as well. And that's going to be like MGCP, Skinny, SCCP, SIP, those type of things that we're going to talk about today. And that'll probably take up, most of the day. It may even run into tomorrow depending on questions and demos and how those things go. Tomorrow we're going to talk solely about CUCM, Unified Communications Manager, and we're going to try to cover everything obviously that's on that blueprint and demo anything that you want to see and try to make the most of that and just give you a good idea of what's going to be on the test there, obviously. Day 3 is going to be iOS applications and features, and quality of service, which is my favorite topic. Not really, but and then also we're going to do security and Cisco collaboration solutions. So that'll be on Wednesday. And day 4 of this boot camp is going to be Unity Connection and UCCX. Unity Connection, obviously the voicemail platform. UCCX is the IVR system. And day 5 is going to be IAM and Present Server, which is going to control your Jabber clients and your SIP proxy type stuff. And then the last thing we'll talk about is strategy for the test, how you should actually approach, taking this test and what's the best method for you to study and that type of thing. So we'll try to cover everything like that. So with that said, any questions so far? Anything I can help with before we get into the actual nitty-gritty of the the lecturing? Thank you, Dan. I appreciate that. I forgot to address this too. There was an email sent out by Simon, who was our boot camp coordinator and support, and he would just stated that there's going to be slide content available right now. And what I'd like to do, because some of it might change, there might be some typos and that type of thing that I find throughout the presentation. I wanted to make sure that everything's correct and cool, so I'd like to get those to you at the end of the week rather than at the beginning of the week. And then it's not like you're going to really need them at the beginning anyway. So I think it'll be a good thing to have the slides at the end of the week anyway, so it'll kind of sum everything up and you can take that home with you. So thanks, Dan, for pointing that out. The video is going to be posted, I'm sure, shortly after. I mean, obviously, for those of you who know, this is one of my first classes that I'm teaching, so I'm not sure what the turnaround time is going to be on that. So I think relatively quickly, though. I mean, I've got the video essentially recording right now, and all I got to do is drop it over to them, and they got to edit it up a little bit for different sections and things like that. So it may be a week or two, could be longer than that, but I don't want to pigeonhole them into a certain time frame. But yeah, the video will definitely be posted, and you guys can access this class at any time after you've taken it, of course. The Volume 1 workbook should be available pretty soon. That is actually something I've been working on in the background, obviously, and that should be available as soon as they post it up. I think there's a couple things that they want to get correct with the interface, and it's actually going to be a brand new interface that we're launching for it. It's really exciting. We're calling it IP Expert Next Generation. So you're basically going to be able to go on and use these workbooks in a cool little interface that you didn't use before. So essentially, I mean, we had PDFs before, and they were locked by DRM, and now you can go on this online interface and click on each question, mark the questions off, write notes. You can also there's also going to be video solutions too for these workbooks, which is going to be pretty cool. If you like looking at my face, which is maybe you don't, maybe it won't be so cool then. So they'll have video solutions, also be the regular solutions. And if you're going to go offline at any time, which you probably will at some point to study, or maybe you study online, whatever, you can export these files to a PDF and take them with you without DRM. So it's going to be a pretty cool interface. Let's see. Online quizzers. Online quizzers are in the process of being written. Actually, you guys are going to be my beta testers for that. So I've got a couple of the questions, actually more than a couple of the questions at the end of the section. What I'm going to try to do is we're going to talk about the topics in the lecture, of course, and then after that, we'll do the the questions. There's probably 2 questions per topic or so, or maybe less than that. but so as to not take up too much time, but just kind of sum up the lecture, and so you guys can cement some knowledge in your head. And so we'll probably use some of those for the quizzers that I'm going to show you here today, and we'll probably do something like that for the quizzers. So, all right, doesn't look like any more questions there. I appreciate the questions, obviously. Keep them coming if you got them. So, let me switch over here. I'm getting used to the interface too, so bear with me. All right, so I got the slides up now for the collaboration infrastructure section. So collaboration infrastructure is going to talk about, we're going to talk about UC deployment models. We're going to talk about power over Ethernet, which is how you power your phones, of course. Your network services such as TFTP, NTP, DHCP, voice and data VLANs. We're going to talk about actually how you get those phones to register and the traffic to go over those networks there using voice and data VLANs. IP routing and Cisco collaboration solutions. So this is basically going to be, when I saw this on the blueprint, I was kind of like, all right, so what kind of IP routing do they want us to do here? And of course, if you've looked at the blueprint in advance and you're kind of familiar with some of the technologies, Service Advertisement Framework utilizes EIGRP. So that's kind of like what they're talking about with the routing there. But also, there's stuff that we'll talk about in the section, obviously, but there's routing between VLANs and that type of thing. So different types of routing that you should be familiar with at the very least. So we'll talk about IPv6, which is supposed to be coming at some point. Everybody says, hey, it's next year, IPv6, man, it's coming, but we all know how that works out. Just too many things to change. IP multicast, and then we're going to talk about wireless and virtualization in Cisco collaboration solutions. So how those technologies fit in. All right, so the UC deployment models. We have our, first of all, campus deployment model, which is basically where everything is contained at one site. You have, let's say, just a headquarters location, and that's your entire company. And so you have all your collaboration equipment at the one site. You have your communications manager, your media resources, your gateway. Everything is contained in one site. So you have some things that you can do there. I mean, you can use high-quality protocols, high-quality codecs, and you're basically going to have only that local PSTN connectivity. You're not going to be able to connect to any, or you can connect to any other systems, but in this particular model, you don't usually do that. Everything is self-contained. So you can use a higher quality codec. We'll talk about the different codecs eventually here, but there's just right off the bat, G711, G729, your standard high and low quality codec. I should say low bandwidth, not quality, I guess. But the higher quality codec, of course, you can use in the campus model because it's all going to be on your local area network. So that's the differentiation. Everything is on the LAN at that point. The centralized deployment model is where servers reside at the same location, but resources can be dispersed. So in a centralized deployment model, you can have basically the same thing as your campus model, except that now you can have sites elsewhere. You can have a couple different sites that are connected to this location. So sites at, well, there's a little bit of a typo there, but remote sites connect to a hub location is what it's supposed to say. And what that means is you can have, just a regular, 2800 series gateway or something running a PSTN at a remote site, and you can have those phones register to your centralized cluster. So it's a pretty popular model for a lot of different customers to run. A lot of customers that I used to work with ran some form of the centralized deployment model. So it says here, QoS, SRST, and AAR are usually deployed with a low bandwidth codec. So quality of service, of course, is going to be necessary because you're now not on just your LAN anymore. You're communicating over your WAN. So you're going to have the routers that are going to be communicating back to the central server to call other sites or between sites over that WAN. So you need to make sure that the QoS is set up, quality of service is set up to prioritize your VoIP traffic, video traffic, signaling traffic, anything else that you might have that's important. Obviously, QoS plays a huge role in it. SRST, which we'll talk about a little bit later in the week, is survivable remote site telephony. And that's going to be an option for you to basically keep that site running if there's a WAN link failure. And the other thing, AAR, is automated alternate routing, which again we'll talk about a little bit later. But that will allow you to route to a different destination if there are bandwidth issues, like there's lack of bandwidth between a certain site. So from site 1 to site 2, you run out of bandwidth based on your location's value, which again we'll talk about a little bit later. Then you can reroute using AAR. That's what that really involves there. The distributed deployment model is kind of a combination here. I mean, you could have one central site, you could have multiple sites. It doesn't really matter. I mean, as long as you have a publisher somewhere that's able to be reached by all these different servers, that's completely fine. It's basically you have a publisher, let's say it's located in a data center somewhere, and then you have other servers that connect in a clustering over the WAN scenario, where you actually have a cluster built across different sites in the WAN. So that's another popular model, of course. You don't even have to use CUCM for this. You can also use CUCME, any other type of call processing agent, third-party system. It doesn't matter. It's going to be in a distributed fashion. So there are a couple things that might be useful when you do have some type of system like that. You might have a session manager edition cluster to help centralize your dial plan, and that would basically take all the DIDs from every different site, put them in one location so they can easily be routed to other clusters. And that's a pretty good advantage of that. I'm going to go ahead and actually draw this out for you. And then you can tell me how bad my drawing is. But we have the first option. Whoops. Well, that's bad already. First option was where you have your CUCM, you have your gateway, and switches, routers, media resources. Everything is all contained at the one site. And of course, from your gateway or gateways, and you can have a million of them, it doesn't matter. You can connect it to that pretty little cloud there called the PSTN, and that is the way that it's the only point of egress on the system. So you have all of your media resources, and everything is contained within that one location. Everything's on the LAN. So if I talk about now the centralized model, so we have CUCM at the center of it all, let's say, in a data center. And now you have several different remote sites connected to CUCM. And of course, they all have, phones. And these links actually right here, I'm pointing at the screen like you can see, I should actually point right here. The links that you see right here are all WAN links. That's kind of what we're talking about here. They're all going to be running IP or some form of IP to get you from point A to point B. So like if I actually put these in a little site, so you can kind of understand what that is a little bit better. So site A communicating with CUCM, that's going to be over the WAN link. And of course, each of these gateways are going to have a PSTN link as well. So you'd have a cloud there, and cloud here, to PSTN, and a cloud on this site. So they can actually get out of the site locally. You can also optionally, even with the centralized deployment model, and in many cases with the centralized deployment model, you don't have to have the PSTNs. You could have a centralized PSTN using a session border controller, or session manager edition cluster with a session border controller, or you can use this central cluster right here. Basically what that would be is you have a router, or let's just call this the cube right here. Sorry, that's a little small. I'll do better next time. And then that would be connected to the PSTN using SIP. And now everything is going to be using those WAN links. everything's going to be using the WAN links instead of the PSTN. So that way, everything essentially goes through one location rather than several different PSTNs. So that saves on cost, of course, and there's a lot of different reasons why you might want to do that. But it basically is going to force you to beef up your WAN bandwidth or your QoS, whichever, depending on how many users are at each of these sites. So if you have, 2,000 users at one site that's connecting, remotely to a cube or whatever for their PSTN connectivity, you need to be able to support, however many busy hour call attempts are going to be sent over that link, to provide the bandwidth necessary, and also prioritize that bandwidth using, DHCP EF for voice and video for AF41 and signaling for CS3 and that type of thing. But like I said, QoS is my favorite, so I gotta throw in some plugs where I can. The next one was the distributed model, which is basically the same type of thing. You're just going to have a bunch of different sites, running Call Manager, or they don't even have to be running Call Manager. One could be running CME. All these I'll just put dots in there so you kind of know what I mean there, and then CME. So basically, you could have this server over here as your publisher, and then you have your big WAN link in the middle that everybody is connected to. And these servers here, like server 1, server 2, server 3, they're actually going to be connected to this publisher server, and there's delay requirements. I think it's 80 milliseconds delay requirement on that. To run a clustering over the WAN service, which basically means that all this database replication, I could change color here, how about that? Database replication is running over the WAN to all these different servers. So obviously with that, if everything's running over the WAN, the first thing you should think of is QoS. So QoS has got to be there for that too. And the amount of bandwidth is got to be is got to be appropriate for that as well. So hope that makes sense there. It doesn't look like I have any questions on that. I just wanted to get that going. I know the diagrams are very pretty. I know that you gotta like that, man. That looks good. All right, back to the slides here. Back to the fun. All right, so moving on to power over Ethernet. This is one of those kind of dry topics, I think, that they kind of choose to quiz you on things that you might actually be able to look up somewhere. So that was always a frustration of taking written tests, is that they'll ask you, for example, what's the voltage provided by the pin 3 on your Ethernet cable, for power over Ethernet. It's like, okay, maybe some people know that right off the top of their head, but that's something you can easily look up. But got to remember, this is the written test. This is what they're going to quiz you on. So I want to definitely prepare you for that type of information. So this is one of those examples, where you might see something like this on the test, where they say, Cisco proprietary PoE. How many volts DC is that providing? Then they'll give you a multiple choice, and you have to kind of figure that out. So keep that in mind, when you see these numbers, and you're like, all right, those numbers don't really matter. They, ultimately you can look them up later. You're an engineer, you're going to figure something out for a customer. You're just going to say, I'm going to get the correct answer, for sure, and look it up and make sure it's right. Well, instead of just shooting from the hip like you have to do in the exam. So anyway, just wanted to point that out because that's something that always frustrated me. So shouldn't that be 48 volt, not 0.48? I don't think so. Maybe it should be. I'll have to look that up, guys. Sorry about that. But let's go through this slide here real quick. So obviously some of this stuff is a little bit elementary, but I want to try to hit everything, pretty hard. Just I want to try to get everybody that's maybe not seen this stuff before. So supplying a power to a phone, obviously the easiest way to do that is with the power brick. You can order a power brick and plug that sucker in and light it up pretty easily. The other couple options are we're increasing in coolness as we get down this list here. So the second one is the mid-span power injector, which I thought were really cool when they came out. So basically it allows you to put this little device in between your switch and your phone if your switch doesn't support PoE, and power your phone using that. So it's just one cable in, one cable out, one goes to the switch, one goes to the phone. And it's able to obviously transmit your data from the phone as well, but that'll power up your phone for you. And the most common option, of course, and what you're going to see in the CCI collaboration exam is inline power. So that's power that's provided by the switch. And these two protocols that we have down below here are going to be related to this inline power here. So the Cisco proprietary PoE is 48 volts DC. Thank you guys for pointing that out. Little typo there. And it's a perfect example of what I was talking about there. It's like, that number doesn't matter. Yes, it does. So it's at up to 6.3 to 7.7 watts per port for Cisco proprietary PoE. And that's going to be using pins 1, 2, 3, and 6. And one thing that is important is the mechanism that it uses to detect whether a device needs power over Ethernet or not. It's called fast link pulse. And what it does is just sends a little ping out essentially with this 48 volts. It'll kind of just, it's almost like wink start. It'll just flicker on real quick. And then if it gets a response back, then it knows that it needs to power that port up essentially. So that's called fast link pulse, or FLP. The one that's most commonly used nowadays is IEEE 802.3AF PoE, which is 48 volts DC as well. And you can go up to 15.4 watts per phone. So if you look in your CDP configuration, which we'll look at in a minute, you can see the actual power that the phone is using, and a lot of times these newer phones are using 15.4 watts. You can see that the data pins are a little bit different. You're using 1, 2, 3, 6, or 4, 5, 7, 8, but not both. So you can use one or the other essentially. And the way that this is going to detect whether a device needs power or not is through resistance. So you have 25 kilo ohm resistance detection when either a range of 2.8 to 10 volts is applied. So you're going to be able to detect that based on the resistance that's provided. So yeah, that sounds good. Yeah, so the major difference to note here is that one uses a pulse and one uses a resistance between the phone and the switch. All right, now moving on to network services. Any questions on that, by the way? Shout them out at any time. Dynamic Host Configuration Protocol, DHCP. Domain Name System, DNS. Trivial File Transfer Protocol, TFTP. Network Time Protocol, NTP. Cisco Discovery Protocol, CDP. And Link Layer Discovery Protocol, LLDP. All of these are different network services that are absolutely essential to your Cisco collaboration success. So if you don't understand any of these services, you're going to have a problem. Dynamic Host Configuration Protocol is the first thing we're going to talk about. And I'll start saying DHCP from now on because that's just way too long to keep saying. So the point, obviously, is if you've been in networking for a little while, you know that the point of DHCP is to assign IP addresses to devices on the network. That's the entire point. I mean, so you don't have to go around and manually configure IP addresses for everything. Definitely not something that would be fun to do. So DHCP will allow you to send that IP address to a different device. It's going to give you DNS settings. Option 150 for your TFTP is very important in unified communications. You're going to need to send that out. And there's going to be an individual DHCP scope per subnet on a VLAN. So when you think about what a VLAN actually is, it's a virtual LAN, right? But it's a separation of routing. So you're going to have different networks residing on a VLAN. So you might have, to make it easy, /24 here, /24 on another VLAN, and you need some way to route between those. But there's going to be an individual scope on each of those VLANs to provide IP addresses, of course, because you can't have, one scope that's going to send to multiple VLANs unless they're on the same network. So there's going to be an individual scope per VLAN. And there are a couple different devices that you're going to use in the collaboration exam, or that you're going to see in the written exam is the CUCM DHCP server and the iOS DHCP server. So the CUCM DHCP server I found to be completely flaky. And I'm sure that a lot of you feel the same way, especially those of you that work at Cisco. Um, it's I would say it's not something that's commonly used unless it's a smaller type site. I think a lot of corporations are going to use like a third-party DHCP server, that type of thing. But the option is available. So CUCM DHCP server is definitely an option. iOS DHCP server, another thing that's available for you for basically remote site type things, or smaller corporations that are running CME or whatever. But iOS DHCP is possible, of course, to assign IP addresses to those devices that are residing on your local LAN there. And the third-party server, like I mentioned, is probably the most popular option in all reality, to provide IP addresses to different phones and endpoints and that kind of thing. Option 150 I already mentioned, but it's super important, so it bears mentioning twice. It's the way that your IP phones are going to be able to get that TFTP server address sent to it. So otherwise, they don't know what call manager server to register to. The thing about TFTP servers is that basically, you can provide redundancy depending on where you want to connect. I mean, you can say that, for example, like you have a call manager group in call manager that's defining your servers that you're going to register to. You don't have to have those as your TFTP servers at all. I mean, they're completely separate. You can have a TFTP server running somewhere else, not even on call manager if you wanted to. But as long as it has a configuration file for that phone pointing towards the server, you're good to go. So this option 150, moral of the story, contains the TFTP server IP addresses. Very important for you to understand in order to understand UC. DHCP lease time defines IP address retention, so how long you get to keep that IP address based on your lease time. So it's, different schools of thought on when you should have your lease time. Thoughts are maybe it's more secure for you to have an IP address lease time that's shorter, or, that way it has to refresh all the time. It doesn't really matter. It's really up to the administrator on what they want to do there. But the point is that you can define the lease time and that it can vary based on different deployments. Phones are going to request a new IP address after half the lease time is expired. So that's in order to kind of stay ahead of the game. They're going to make sure that everything's taken care of. They've got their address locked down, and they don't have to keep renewing basically. But they're going to request, and the DHCP server usually just say, "All right, cool, keep it. You're good." So when you have these third-party DHCP servers, it's important for you to understand the concept of DHCP relay, because a lot of the times they're going to be in some location that's not necessarily on your LAN, and you're going to have to forward requests to those servers. So if you're on your local area network somewhere, like let's say on iOS, because we'll talk about DHCP relay on iOS, you want to configure your interface to forward these DHCP requests to a third-party server or a different IP address, maybe not necessarily on your LAN. You at least have to have a route to that server that you're forwarding to, because basically what happens is the phone will broadcast out, "Hey, I need an IP address," and then that port will respond, "Okay, cool, I'm going to send the request to the DHCP server that we have set up here for the relay." But then it's going to look through the routing table and see if it can actually get there. And of course, if it can't, then you can't get an IP address, because there's no way for that communication to happen. So, of course, if you have the route set up in there, which is not part of the scope of the test, of course, but you have to know how it logically works, then you can get that IP address set up. So DHCP relay is a pretty popular option, used in a lot of different customer deployments and so forth. So, but for the lab and the written exam, great information to know there. All right, so here's a quick example, and actually I can show you in Communications Manager. It'll probably be a little bit more exciting, right? Let me pull up the actual server here, and we can go through and look at it. And once again, this equipment here is the racks that we have set up. Are the racks that we have set up in Proctor Labs for rental for the CCI collaboration, of course. So nice little demo for you here today to check out the speed and the the usability of the servers and such. So if you want to configure DHCP on Communications Manager, you have to go to System menu, DHCP, and you have to first configure your server, which you can do right here, or you can configure your subnet as well. You need to have a server configured to configure your subnet. So if we go in there and check it out, there's actually none configured. So we'll hit the Add New there, and right now on this particular server, this is the HQ cluster that we have, which has 2 subscribers, or 2 servers, 1 publisher, 1 subscriber. So this .12 server is actually our subscriber. So if we wanted to handle or have that server handle the DHCP requests, we could add this server here, add all the different options, of course, and then let me go ahead and add one here real quick so we can show you the subnets. So this primary DNS address, you're not normally going to use DNS in the network. We'll get into that. Primary TFTP server. If you have a larger cluster, of course, which you're not going to have in the CCIE lab exam, you might have different TFTP servers than your actual subscribers. But in the lab exam and different and the written exam, of course, I guess you could talk about multiple different options, but in the lab exam you only have really 2 options. So your TFTP server running on the same server as your subscriber. So we can put in here 10.10.13.12, and then our secondary TFTP server IP would be 10.10.13.11, which is not a good best practice because that's the publisher server, but it's the CCIE, we don't care. We only care what's possible in the CCIE. So let's hit save there, and we'll go to System now, DHCP and DHCP subnet. And then we'll go ahead and add new here. Sorry, I missed the question there. If neither was the DHCP server, is there any reason you would put the foreign DHCP IP here? No, actually, that's a good question. But if you have a third-party DHCP server, it would not go there. This DHCP server configuration is only to control that on Call Manager. So when you're using Call Manager as your DHCP server, this is where you're going to configure it. And so that third-party server would just be configured somewhere else, and we would just have to connect to it through a DHCP relay, or if it was on your local LAN, just sit there and let it give you an IP address. So now we have the DHCP subnet page up, by the way. So we have the DHCP server we can select here, which is going to be .12, which we just configured. And now we can do the fun part, which is configure the subnet. So let's just say our subnet here is .11 or 10.10.11.0/24, which is a Class C, if you're going by the specification there. So we'll add 10.10.11.0 as a subnet address. And this is one of those areas where, you can definitely easily get confused, in high pressure situations, which you're going to experience, of course, if you're going to be taking the collaboration lab. This is an example of one of those situations you might face where, all right, I gotta figure out, what IP address to put in here. It's I'm not sure where to put it. You put it in the wrong place. You have problems. You can't figure out why. So my advice: just take it slow, calm down. It's gonna be all right. Just take it step by step and just read the columns here. Go easy. So the primary start IPv4 address. So if we're gonna start the DHCP handoffs, basically, we're gonna give people a IP addresses in a specific range. You can put that here. If you want to just specify the entire range, you can. So that would be .1 to .254. We'll make the primary router address .1. Whoops. And probably you want to change your start address from something other than .1 because you can't assign that. It's your default gateway. So let's make that 2 instead. And then we'll have to put a subnet mask here. And this is the most commonly missed parameter. 255.255.255.0, which is your /24. And then we have the option to put TFTP servers here in the configuration, but we don't necessarily have to do that here if they're already defined in your DHCP server configuration. So I remember that we did that, so we don't need to put them there. So I hit save, and then now your configuration is complete. So a couple questions here. Let's see. Thinking the only time you'd ever use this is a collab lab. Quite possibly. Yeah, I'd agree with you. I mean, it's not something that's used a whole lot, but definitely necessary to know for the written exam and the collab lab exam. So that is how you configure your DHCP server. Of course, this is also controlled by a service within Unified Serviceability. If I go to Unified Serviceability here and go to Tools, I believe it's in Feature Services, and select our server, which is .12. You have this DHCP monitor service here that is basically going to, control the entire DHCP configuration that you have there. So you have configuration in the server. This service, if this service is not running, it's not going to work. So definitely an important thing to note there. But let me get back to the presentation now. Don't want to spend too much time on that. The next one here is your iOS DHCP server. I'm going to put the configuration here so we don't have to really go to the lab if we don't want to. If you guys want to, let me know. I'll jump in there and we'll look at it. But this is the same type of thing. This is defining IP addresses for Site C. So we have HQ, Site B, and Site C in our IP expert topology. This is Site C, which is going to be our emulated international site. And in our case, it's going to be Germany. So we have here the IP DHCP excluded addresses. In this case, does anybody know what actual range this is going to generate? What IP addresses are going to be yielded from this configuration? If you know the answer, go ahead and just type it in the chat window there while I'm talking. The pool here, the pool defined as SC for Site C, is going to use that 10.8.97.0/24 network, and you can actually type it in as /24, and it shows up as this subnet, the actual subnet mask. And then we've defined a default router here, which is going to be your default gateway, the way that you're going to get out of that LAN if you're going to external places, which you most likely will be. And the option 150, of course, is your TFTP server that you're going to be defining, which could either be a local TFTP server for CME, which is the case here, or could be something somewhere else, as long as you can get to it. So we have a couple answers here, 20 to 29. Nice. Good effort. I like it. Good feedback on that. So yeah, that's going to be the DHCP addresses there, 20 to 29. It's a good idea to know how to do that. Know that that's an option for you at least. I mean, you don't have to just open the subnet range up to everybody. You can kind of specify what you want. So, all right, let's move on to DNS. So you guys use DNS every day. Everybody uses DNS every day if you're browsing the internet. Of course, you don't, want to remember a stinking IP address to go to ipexpert.com. You want to just type in ipexpert.com. So that's what the purpose of DNS is name resolution. So if you have ipexpert.com, you want to be able to query a DNS server and have that DNS server spit out an IP address at you. So that way you can actually make the connection. Because the connection is actually made with the IP address. It's just the name itself is just an alias. DNS is definitely able to be used, and it's used a lot of the time in collaboration networks, especially in customer environments. But be wary of doing DNS, in these type of situations, only because that DNS can be looked at as a point of failure. I mean, you have a DNS server that, obviously it's going to be redundant, or you should probably make it redundant if it's not. Because if that DNS server goes down and you have your whole phone configuration based on a DNS name, you can't get to the server at that point. You're screwed. You have to communicate via DNS, which you don't have at that point. So if DNS does not stay up in your environment, it's a bad day for everyone. And as one of my former instructors used to say, resume generating event. So that means you're looking for a new job. So DNS is not used some of the time because of that. It's, let's just use IPs. Let's go from phone to server. and not have to worry about DNS. Let's just make sure that we don't have to have that other point of failure in the network. So some people, want to go that route. So if you want to do the IP only type of thing and use IP communication from your phone to your cluster, it's important then to set your service parameters and enterprise parameters as such to allow your phone to communicate with the server using only the IP address. And it's not just the enterprise parameters, it's also the server name. So if you have a server name defined as HQ-pub, for example, you might want to just change that to the 10.10.13.11 address that we're using for that. So that way your communication can for sure 100% happen at the IP level if you don't have DNS in your network. So does this recommendation apply to unit connection, IM presence, IP instead of DNS? I would say that yes, it does. I mean, you can use. Thanks for the question there, Alan. By the way, you can use IPs only for communication if you're using these different servers. I mean, of course, you can use DNS if you want to. If that's a requirement of the lab exam, or if that's a requirement of the question in your written exam here, of course it's possible to use, but it can be done with IP only on every single server in the topology. Good question though, for sure. The enterprise parameters, let's go look at that right now actually, and have a look and see what parameters we're talking about. I think I actually put it in the presentation too, so I could have just gone to the next slide, but it's much more fun to do the demo, I think. So if I click on, so by the way, I'm sorry, I'm going to System and Enterprise Parameters. I want to make sure that I kind of point that out. And scroll down a little bit here, and you'll notice the IPs that are set up right here now. But normally, let's say that you named your server HQ-pub. HQ-pub would be listed just like that in the configuration. So this would be for the URL authentication parameter for the phone. So when the phone gets its configuration file, it's going to get all these IP or these connection parameters to the phone. So when it tries to make, for example, a connection to the directory's URL, it's going to be using by default the host name instead of the IP address. And if you don't have DNS in your network, it can't resolve that host name. So it's important here, if you don't have DNS, to change this back to the IP address. I can just hit undo there, and basically there are duplicate parameters here for the secured phone connection. So in addition to these enterprise parameters, we'll go change the servers as well. So if you go to System Server, hit Find, that'll show you all the servers in your system, of course. But you have these servers that have actually already been changed, and you have HQ-pub. What I usually do is, obviously the name will come up here in this highlighted area as HQ-pub. I'll change that, to the IP address, but then I'll also go down to the description and put that host name in there, so at least I kind of know what it is. If I don't remember the IP address, that's useful in customer environments too. Little tip there. So, any questions on that? What's the point of the MAC address field? That's a great question. I'm not really sure, honestly. I don't think I've ever used it. I think, well, yeah, let's do that. Check out the documentation. Thanks, Julius. By the way, for those of you who don't know, this is a super useful thing to do when you're studying for the written or the lab. Go to the help section, and normally a help is just not helpful at all, but this is really good. Help this page usually will take you to something very useful about the particular page that you're looking at. So this one, server setup, let's see, we'll just look for MAC address. Can I do that? Let's see here. I don't see it. Anybody see it in there? Well, yeah, I don't want to spend too much time on that basically, but I've never used it. I don't want to sound arrogant. I've never used it, and I have a CCIE in collaboration. So, just kidding. I mean, I'm sure it's useful in some respect. But I'll have to find that out and get back to you. Let me write that down here so I know. Thanks for the question on that, though, Julius. Okay. So, what Dan says on the left menu. Oh. Down two more. Oh, server settings. Thank you. Okay. The field is optional. It exists only to give you a place to note the server MAC address. Okay. So a lot of the times you're going to be noting that MAC address in some other form. A lot of times it's going to be a database or a spreadsheet or something, or the design documentation that you have. It's good to have though on the system. I get that. So thanks. I definitely learned something today. Hope you guys did too. Appreciate that, guys. That's how we work together right there. That's good stuff. All right. So let me go to. All right, back to the presentation. So that's DNS. I think if you have any questions on DNS, just let me know, of course. We'll move on to the next thing, though. And here's a screenshot that I was going to show you, but decided to just show the server. What we just talked about there, IP address has been changed. And we have the IP addresses here listed in the field instead of the host name. All right, now talking about TFTP, we talked about it a little bit already, but it's very crucial to the UC network. If you don't have TFTP, you really can't, register a phone. I mean, it's just as simple as that. That's the protocol that's used by the phone to communicate with the server to get a configuration file. And the configuration file is going to contain, things like, the servers that you're going to register to, the different configuration that might be found in your device pool, any media resource group list that you have, that type of thing. But it's very crucial to the UC network to have the TFTP server up and operational, and whether that be a third-party server or a communications manager server or whatever it happens to be. You can also use iOS for TFTP, not even just for CUCME, but also for different servers. If you have a configuration file that you want to host somewhere, you can pop that up in iOS and have a phone downloaded if necessary. So the TFTP server itself is going to contain files for phones, gateways, and other endpoints, and you're going to have phone firmware files in there. So, for example, if your phone tries to register with a cluster and it has a firmware load on there that is incompatible with the current load on the server, meaning that the configuration of the server somewhere says, hey, I'm running load 941 SR1 or something, and your phone is running 93 SR2. Well, now there's a discrepancy, and the minimum version required by the cluster then is this 9.4 version, and now you have to load, this other firmware file. So what that does then is contacts the TFTP server, of course, going to pull that firmware file down, and you'll see. I'm sure you guys have seen that before. The phone says upgrading, just downloading the file over the network. There is all that really amounts to. CCM 8.5 is end of sale. Oh, sorry. Wasn't a question, I was just curious. All right, next thing, phone configuration files. I already kind of mentioned that, the different things that are in the configuration files. You're also going to have, if your server is secure configuration, which is basically now by default, since 8.0, security by default, you have CTL files and ITL files, which are certificate trust list and identity trust list. And those are downloaded automatically to the phone to secure that communication. So, and that can obviously be a problem when you switch phones between clusters, because you figure you have this phone downloading a security file, a certificate that says, hey, you can only register to this trusted list of servers. And that by default is going to be the servers that are listed in the cluster. So if you try to go to another cluster at that point, phone registration will be rejected because you have a certificate that doesn't match the certificate of that server. So there's parameters to deal with that, set rollback parameters, pre-rollback or something like that in enterprise parameters. and also you can just delete the CTL file from the phone or ITL file from the phone to deal with that. So that's one thing to definitely note about those different types of files. Tone localization files, you're going to see different ringtones, different ring back tones that you might hear for different countries, so you can load those. Ringless files, soft key and phone button template files, and background images. So just important to note these different files that are going to be on your TFTP server. All right, so the different TFTP applications that you have available to you in the network here is the CUCM TFTP server, of course. We talked about that quite extensively, but it can also support this proxy TFTP option where you're basically designating another server to run your TFTP service for you. And then so your phones, like for example, if your phones are at a remote location that has a slow WAN link, back to the central TFTP server, it might be a good idea to designate a proxy server or proxy TFTP server to be closer to that location. Also, it could be used as a centralized server option. So that way, like if you have this proxy server can run at a central location, so that way everybody uses that one server if you have multiple clusters. So that's a pretty cool option too if you want to use that. The load server option, you can specify, on the phone configuration page that will allow you to point to a non-CUCM TFTP server. Whatever, it just has to run this TFTP protocol, that's all. So you just specify that in the phone configuration page, and that will allow this server to download their configuration files from this other server. That's really all that amounts to. The peer firmware sharing is pretty cool too. I mean, so let's talk about, first of all, what it's like without peer firmware sharing. A normal configuration, you have your phone connecting to the server. It sees that it needs to upgrade its firmware for the phone. So it starts downloading the firmware. It's got to download, like say, 6 or 7 files or so from the server. And it starts doing that, and it's taking a long time, and there's a lot of, they're big files now, especially for these SIP phones. These SIP 9971 phones are pretty huge. So you're downloading these over the WAN, and if you have a low bandwidth WAN link, you're going to be waiting a long time. Well, if you use this peer firmware sharing and you have multiple phones doing this at once, upgrading their software, then it's a really good idea to engage this peer firmware sharing, because what it does is say, hey, you're downloading that same file too? Great, I'm going to download that, and maybe we could do that together. So like one phone will take one file, another phone will take another file, another phone's going to take another file, and then they'll all download them separately. And then when those files are downloaded, they'll host them to the other phones. So basically, you can have a local LAN connection, to download this file from another phone rather than a WAN connection. Significantly cuts down on the WAN traffic, WAN bandwidth that's necessary. So definitely a good option. There's a couple different things that you have to take into account though. The phones have to be on the same subnet. They can't be across different subnets. So that, if you have a hierarchical setup, like most LANs do, I mean, they're not going to all be flat these days. So you have to download the file multiple times, because you're going to be on different subnets probably with some of these phones. So that's the number one thing. They have to be on the same subnet. Number two, have to be the same phone type, of course, because if they're different phone types, they're going to be downloading different files. So it's important to note that they're going to have to be the same phone type. And also, another thing with timing is that they have to be pretty much reset all at once, or they have to go down all at once and come back all at once. They have to be going through this firmware process pretty much at the same time. And that way, if they do that, then they're able to figure out and sync up together. There's a whole algorithm behind it for how that all works, but it's really cool, how it's set up there for us to use. But if peer firmware sharing is unsuccessful, as you might imagine, it's just going to fall back to the normal CUCM TFTP option there. So it's going to take this TFTP server that I would normally connect to and just connect. If there's 50 phones, there's 50 different connections if it fails. So it's a bad day if it fails, because it takes a long time and oversaturates your WAN bandwidth there. Any questions on that? Everybody cool with that? Does peer firmware sharing only use TFTP or does it use HTTP? Peer firmware sharing is kind of its own protocol for how these phones talk together. It's not necessarily using TFTP or HTTP. It's basically TFTP is used as the first step, and then these other phones register to the TFTP, or not register, but grab this file from the TFTP server, and the protocol used between the phones now is this peer firmware sharing. Without TFTP or HTTP, it doesn't really matter what protocol it is. It's TFTP is just the way to get there, to get to the phone. So I hope that answered your question, Scott. Is peer firmware sharing secure? I don't believe that it is, actually. I haven't seen that. I think that, you know, basically it's going to be on your LAN anyway. It's not going to be something that can happen across a network. So if you're worried about security on your LAN, of course, then it could be an issue, I guess. But I don't know. I guess maybe somebody could sniff the file, you know, or try to grab the file down or whatever. But it's at that point it's a firmware file, so nothing crazy. It's going to be a firmware file you can just download from cisco.com. So maybe they found the need to not have security for it. So I don't think it is secure though, Mike. All right, moving on here to the phone and TFTP interaction. So I guess I've kind of talked about this throughout, you know, to kind of give you some context on what's going on here. But just to go through it to make sure we hit everything here. Phone receives DHCP information containing the TFTP servers. So of course that's the first step. You got your DHCP server dishing out your option 150, and then that's going to tell you which TFTP servers to go to, and there can be multiple in the list. So the IP phone then contacts the TFTP server to request the firmware configuration, and then the TFTP is going to send the configuration back, of course, and then you're going to get the most important thing that you're going to get out of it is the CUCM server that you're going to be registering with. Also, this XML config file is downloaded the XML config file that it has in the system for that phone, like let's say that you actually configured the phone already in the system, it should have a configuration file just rearing to go, just rearing to get on your phone. But if you don't, it's just going to use a default one or not register with the cluster at all. The default one would be used if you have auto registration. It would generate a XML configuration file there. The file contains firmware load information, of course, because it's got to know whether you're running the current firmware that's required on the cluster. The decision is then made on the phone whether to upgrade, that phone firmware, based on those two different pieces of information. So the next thing that it does after it gets the configuration file, it's got to download the soft key template, phone button template, any other specific configuration that you have on there, and then the phone will register with the first CUCM cluster in the list. So if you have, you can have a couple different clusters in there. I don't remember the exact number to look at that, but you can. I think it's up to 3 or 4. But if you have like an SRST reference, which we'll talk about later, survivable remote site telephony reference, that will show up as the last server in your TFTP list on your phone if you go look through the settings. So any questions on that? I think I don't know if there was another part of that section there. All right. The next thing, sorry, just bear with me. I got to grab some hydro. All right. So NTP is another one of those critical services. You're sensing a theme here. Like all these network services are critical for the operation of the phones. I mean, phones, all the phone features, all that stuff is great. Video, everything that you can do with the phones. But if you don't have the underlying network technology and topologies and things to take care of these bottom line services, then it's just not going to work how you want it to work. So NTP, with that in mind, is another one of those critical services, which is network time protocol. As you might imagine, the purpose is for other devices in the network to just synchronize their time off of a local server, off of a remote server, as long as you have access to it. So, for example, you could have a router like R. So we have, let me just kind of break it down for you. We have the HQ site, which has R1 as its router, site B, which is SB, which has the R2 as its router, and then we have site C, which has R3. So if we're on, R1, and we want to use R1 to provide NTP services to other devices in the network, we have to set that as a master server, and then so that basically every server will synchronize off of that one time. So the time better be correct on R1, or else everybody's going to be off. So you can obviously put that NTP server anywhere you want. You can register NTP server externally. It doesn't really matter as long as you have access to it, and as long as it's a proper stratum level, which is the last thing here. So it's very important to all UC devices to ensure the correct time is there, because you have these IP phones that are going to be registering with the cluster, and they have to have the right time, because you're going to have people relying on that time to be accurate, for different meetings, or when they're looking at their phone to see what time it is. I mean, that people are just used to that at this point. So that time has got to be correct. It's also not just for end user display, but it's also for like log files and synchronizing times across different servers. So let's say you're troubleshooting an issue, which if you're attempting the CCI collaboration exam, you will be doing. You'll be troubleshooting like crazy. You have to make sure that you have your time synchronized, because if you're looking at, say, a CUCM server on one site and iOS gateway on another site, and somehow they are involved in a call flow, and you want to correlate those two, it makes it so much easier if you just have that time synchronized, because then you could say, all right, at June 16th at 10:22 a.m. and 34 seconds and 42 milliseconds, we had this SIP SDP sent out, and then okay, I got that over here at 0.34 milliseconds or whatever. So you can verify communication that way. It makes your life a lot easier, that's for sure. So very important to have your network time protocol synced up. So also it says here for call detail records, and I already talked about phone display. So call detail records are just a part of the system where that basically logs every call that goes through that's less than a second, I think. I mean, there's a service parameter in there to change that if you want, but it will basically log every single call, and you can go in and look at the history and see who called where and that kind of thing. So that's what a call detail record is. And so if you have the correct time on there, then you can say, I see that user A called user B at this time, and that maybe will help you troubleshoot a problem down the road. So I think I've hammered that home, why it's important. But like I said, it insists in correlating events, and you have your CUCM publisher by default as the NTP server for the cluster, because your publisher is going to go out and actually synchronize with the NTP server itself, and then you have the other subscribers that are going to be connecting to that publisher. And so that'll be the way that they synchronize their time through that publisher. Publisher syncs to your external NTP server. So the next thing here is the stratum level. Stratum is just basically just another word for accuracy, of the NTP server. So if you have a stratum 1 server, that means it's deadly accurate. And as you go down the list to like I think it goes to stratum 15 or so, that just gets to absolute crap, So not that it's that bad, but stratum 3 or better is recommended for external NTP servers if you're going to connect to them. So that, just to make sure that your time that you're synchronizing with is going to be absolutely correct. Your NTP servers need to be synchronized with a stratum 3 or better. The next thing here, SIP references are necessary for CUCM SIP endpoints. And what does that actually mean? So we already have our server synchronized with the NTP server. Skinny phones don't need any phone reference because they're actually using the time that's provided on the server itself. Well, a SIP phone's a different animal. It needs to be told what to do, a little bit more so than Skinny. It needs to have this phone NTP reference that actually will tell it what server to synchronize with. So it's not able to synchronize with Communications Manager for that. So let me show you that real quick. Actually, let me pull up the CUCM server and just show you the phone NTP reference, which I believe I have configured here at HQ site. All right, so I have one phone NTP reference here. This is the loopback address of R1. So I've decided to use my R1 server as the NTP server. If I click that, you can see kind of what it's using here. There's not much configuration to it. It's just directed broadcast. You could do unicast, multicast, anycast, but directed broadcast is the one that's going to be used. So it's directed at that certain phone, essentially. So it's using a loopback address of R1 to do that. And then that phone NTP reference gets assigned to a date-time group. Date-time group is your thing that's going to provide the correct time for your phones on the system, of course. And so now you can assign that in the selected NTP phone references section of the configuration. And then, of course, your date-time group gets assigned a device pool. And I don't want to steal too much information from tomorrow's lecture, so I'm going to stop there. But hope you kind of got the point on what it does and what it is. All right. Moving on here to CDP. I think how are we doing on breaks, guys? You guys need a break? You okay? Well, seems like you're okay. Good deal. If I get too boring and can't take it anymore, just tell me you need a break. We can always take a 5-minute break or so. Break would be good. Quick break. Sounds good. All right. So we've talked about a bunch of topics up until now. We're going to talk about CDP next. In the meantime, take a break. It is 10:27 now. Let's do like 10:35. How about that? So a little bit of a break there. We'll see you back here in a few minutes then.